Question 5. A fair coin, one for which both the probability of heads and the probability of tails are 0.5, is tossed 60 times. What is the probability that more than 1/3 of the tosses are heads? All right, so this question is clearly about proportions, right? So 0.5, that's a proportion. 1/3, that's a proportion written in fraction form. Okay. So to answer this question, we need to know something about the sampling distribution for the sample proportion. Okay. All right, so sampling distribution of p hat. All right, now here's some things that we know. Okay, we know that the true proportion of heads is 0.5. So we'll label this p equals 0.5. And we know that the sample size is 60. Okay. All right, so now that we have those two values, that's really all the information we need to determine the shape, the center, and the variability of our sampling distribution. Okay. All right, so let's begin with the shape. Okay. Now this sampling distribution will be approximately normal if the large counts condition is met, meaning NP has to be at least 10 and n times 1 minus p has to be at least 10. So let's plug in our values and see whether we get a product of 10 in both cases. So this will be 60 times 0.5, which is 30, check. This is going to be 60 times 0.5 as well, so 30, check. All right, so shape's approximately normal. Okay, now we can look up the center and variability. Okay, now this is a question about the sample proportion, or p hat. So on our formula sheet, there's a section, okay, about p hat. Okay, here's the formula that tells us the mean of that sampling distribution. So it's just equal to p, so the true proportion. And then here's the formula for calculating the standard deviation for the sampling distribution. Right. So the mean of our sampling distribution is just equal to the true proportion, so 0.5. The standard deviation for our sampling distribution, so the formula was square root of p 1 minus p over n, which will be the square root of 0.5 times 0.5 divided by 60. And I'll let you know what that is in a second. Okay, so I got 0.065. Okay, all right, so we've determined the shape, the center, the variability, so now we're able to make a sketch. So we're sketching our bell curve for our normal distribution. Label it n for normal. The mean is 0.5. And the standard deviation is 0.065. Okay, so mu for mean and sigma for standard deviation. All right, so there's 0.5 in the middle. All right, so now with this sketch, we can find the probability that more than 1/3 of the tosses are heads. Okay, so 1/3 is equivalent to 0.33. It's actually repeating 3, but write it as 0.33. It's going to be somewhere here to the left. Okay, and we're looking for an outcome that's more than that, so we're going to shade the entire right tail. All right, so just from the picture alone, I can eliminate any answer choice that's less than 50% because we see we've shaded clearly more than half the curve. So I can eliminate B, C, oh, D, and E. Okay, I guess that just leaves us with one answer choice, A. Okay. Now that's not a very convincing argument, just going process of elimination. Let me convince you that A is the correct answer. Okay. Now, since this is a normal distribution, we're going to standardize our boundary value. So 0.33 minus 0.5 divided by 0.065, and that's going to give us approximately, I made a mistake on the calculator, let's try that again. 0.33 minus 0.5 divided by 0.065. Okay, negative 2.61 or 62, I'll round it. Negative 2.62. All right, let me create a little bit more space here. Okay, and then now we'll use table A to do the rest of the problem. Okay, so negative 2.62 negative 2.62 okay, gives us a probability of 0.0044. 0.0044, okay. But this actually represents the unshaded side or the left side. So we just have to subtract that from 1 to get the shaded side. So that's going to be 0.9956. Really squeezing that in there. Okay. It's not a perfect match for the answer choice, but at least the first 3 digits match, right? And that 4th digit, I mean, how significant really is that 4th digit? Not much in this case. The first 3 digits are more important here.